Exceptions to the octet rule, type 3. More than an octet of valence electrons. This is the largest class of exceptions to the octet rule. Consists of molecules or polyatomic ions in which there are more than 8 electrons in the valence shell. This is known as an expanded electron shell. When does it occur? Expanded electron shells only occur in elements in period 3 and beyond in the periodic table. Elements in period 3 have electrons able to bond from the s, p, and d sublevels. The empty d orbitals accommodate additional electrons. The key point to consider here is that you cannot expand an octet in situations where there is no d sublevel. Other considerations. The larger the central atom, the larger the number of atoms that can surround it. Expanded shells occur most often when the central atom is bonded to the smallest and most electronegative atoms such as fluorine, chlorine, and oxygen. Let's look at an example of PCl5. If I look at PCl5, I see phosphorus, one of them with 5 valence electrons. Chlorine, we have 5 chlorines, 7 valence electrons apiece, 35 electrons total, for a total of 40 electrons or 20 electron pairs. So of course when we do this, we want to start with phosphorus in the center. And the main idea, because we are working with 5 chlorines, is that we want to space these chlorines as far away from each other as possible. So I'm going to do one at the top, one at the bottom, one going back into the page, one going out of the page, and one in line with the page. And then I'm going to put chlorines around all of these with their full octets. When I count all of the electrons in the lone pairs and the bonding pairs, I can now see that I have the 40 electrons that I originally started with. Therefore, this is an example of how phosphorus can have an expanded octet. Let's look at another example, XeF2. So let's start with Xe. There's 1 with 8 valence electrons. Fluorine, 2 fluorines, 7 valence electrons apiece for a total of 14. 8 plus 14 is 22 electrons for a total of 11 electron pairs. I'm going to put Xe in the middle. I have 2 fluorines, so I'm going to put them as far away from each other as possible and then give each fluorine its full octet. Now what I'm going to do is count the number of electron pairs that I've used so far. So 1, 2, 3, 4, 5, 6, 7, 8. I've used 8 electron pairs. I have 3 left over. So what I'm going to do is put 1 here, and 1 on the bottom. So that's a total of 1, 2, 3 lone pairs around the Xe, and that is perfectly normal. And that accounts for the 11 electron pairs that we had to work with for this molecule of XeF2. Let's now look at our last example, SbF5. So we have Sb, 1 with a total of 5 valence electrons. Fluorine, 5 fluorines times 7 for a total of 35 electrons. And if we add these up, we get 40 electrons total, or 20 electron pairs. Like we saw in the example with phosphorus pentachloride, we're going to put the Sb in the center. And we're going to have 5 bonds coming off the Sb. So 1 coming up, down, back into the page, out of the page, and in line with the page. And then I'm going to put fluorines all the way around, each having their full octet of electrons. So now when I go around and I count, I can say I have 3 electron pairs here, 6, 9, 12, 15 electrons, 15 pairs of electrons taken up as lone pairs, and then 16, 17, 18, 19, and 20, for a total of 20 pairs, showing this expanded octet.